In this video, I'm going to show you what conversion factors are and teach you how to use them to solve problems. We'll be using this method of problem solving throughout the semester, so it's important to get lots of practice solving problems using conversion factors. So what are conversion factors? Well, conversion factors can be written from any equality and then they can be used to solve problems. So we'll begin by writing an equality. We're going to look at 1 kilogram is equal to 2.20 pounds. Now we can take this equality and write it as a conversion factor. To do that, you simply take one side of the equality and write it on the top of your fraction and the other side of the equality and put it on the bottom. You can flip it and start with the other side of the equality and put that on top. And in this case, we would have 1 kilograms on the bottom. So any equality can be written as two different conversion factors. So let's look at how we will use that in problem solving. So here's a problem. What is the weight of a 145-pound person in kilograms? To begin to solve this problem, you're going to start with the amount that you're given, in this case, 145 pounds. We want to convert this into kilograms. So our conversion that goes between pounds and kilograms is the equality we looked at before. You start by writing the amount that you're given, in this case 145 pounds. And then we set up our problem and we're going to write the conversion factor right next to it. Your units dictate which of those two conversion factors we would use. We need our units to cancel out, and so we start with pounds, so that means that we're going to write the conversion factor that has pounds on the bottom. So that's the first one. 2.20 pounds on the bottom is equivalent to 1 kilogram. Our units cancel, and then we can do the math. So you multiply the numbers on the top, divide by what's on the bottom. So 145 times 1 doesn't change the value, divided by 2.2, and we get an answer of 65.909 repeating. Now we need to look at significant figures to round our answer to the correct number of significant figures. The measured numbers that we have are 145 pounds and then also 2.20 pounds from our conversion factor. Both of those have 3 significant figures, so we're going to round our answer to 3 significant figures. So we would round it 1, 2, 3. There's a 0 next to it. That is not going to change the 9, so that becomes 65.9 kilograms. So a 145-pound person is equivalent to 65.9 kilograms. Let's look at another problem. Here we have a patient is prescribed 500 milligrams of amoxicillin twice a day. The amoxicillin comes as an oral solution of 250 milligrams per 5 milliliters. How many milliliters should be given per dose, and then how many teaspoons? And I've given you the equality for teaspoons to milliliters. So again, we're going to start with the amount that we're given, and the amount is our 500 milligrams of amoxicillin. That's our dose. And we want to know what volume you would be given, so we're going to use this 250 milligrams per 5 milliliters as our conversion factor. So I'll start by writing out our amount given, 500 milligrams. Since our milligrams is on top, we're going to put milligrams on the bottom of our conversion factor to cancel. So we have 250 milligrams and 5 milliliters on top. Our units cancel. And then we can do the math. 500 times 5 divided by 250 gives us 10 milliliters. So that is how many milliliters should be given per dose. Now we're going to take our 10 milliliter dose and convert that into teaspoons. We have milliliters on the top, so we're going to look over here at our equality, and so that 5.0 milliliters will go on the bottom. And 1 teaspoon goes on the top. So 10 divided by 5 gives us 2 teaspoons. So our dose could either be measured out as 10 milliliters or 2 teaspoons. Okay, the final problem that we are going to look at is this. A recipe calls for using 75 milliliters of olive oil. If the density of olive oil is 0.92 grams per milliliter, how many grams would be needed? So the amount that we are given is we need 75 milliliters of olive oil. You are given the density. We're going to use our density as our conversion factor. So if you are given density in a problem and either the volume or the mass and you're looking for the other one, either the volume or mass depending on what you're given, then you use density as a conversion factor. So we start with the amount we're given, which is our 75 milliliters. Since our units are milliliters, we're going to put milliliters on the bottom. So from our density, it's 0.92 grams per milliliter. So it's an understood per 1 milliliter. So 1 milliliter goes on the bottom. 0.92 gram goes on top. So 75 times 0.92 gives us a value of 69 grams. Okay, so those are 3 examples of using conversion factors to solve problems. As I mentioned at the beginning, this is something that we are going to be using throughout the semester. So it is important that you spend lots of time practicing problems. I hope this helps you to understand how to use conversion factors in problem solving.